Okay, next question is we want to solve the differential equation y double prime plus 4y equals to exponent negative 2t given condition y0 equals to 2 and y prime 0 equals to 1. So we want to solve using method of Laplace transform. So what you need to do first, always start with taking Laplace for each term. Oops. Okay, so then is you refer table Laplace y double prime is given by Laplace of y always given by capital Ys. Next, Laplace exponent negative 2t is 1 over s plus s minus 2. Next, you substitute the condition given. Y0 is given by 2. Y prime 0 is given by 1. Okay, next you simplify this. There is ys, so you factor that first. You factor that ys. Okay. And then there is term negative 2s minus 1. Okay. Next, you simplify this because you want to get the capital Ys. So simplify that first. So this is plus 2s plus 1. Right. Okay, simplify this. What you get? This become 1 plus, expand this to s squared plus 4s plus s plus 2, which is 2s squared plus 5s plus 3. Okay, so that means you get ys is, the idea is you just want to get the ys. Okay, so ys is you must rearrange so that you get the ys. Okay, because we want to find the inverse of the ys to get the yt, the solution yt. Okay, now you already get the capital ys. So now we want to find the solution yt. The solution yt always taking inverse of y Laplace transform ys. Okay, so that means we must find the inverse of this whole function. Okay, so that means we must find the inverse of this function 2s squared plus 5s plus 3 over s plus 2 s squared plus 4. Okay, since you look at this is so as usual, to find the inverse you must look at first at the function at the bottom. This is s plus 2 factor with s squared plus 4. So from the table there is no such item, so that you must apply using partial fraction. Okay, so do partial fraction. Which is what is the partial fraction for this function? Okay, so since the function at the bottom is linear or the highest power is 1, so at the top must be constant only. Next second fraction. This is the highest power in this fraction is s squared. The highest power is 2, so at the top must be bs plus c. Constant s plus constant. Okay, now we equate, darab silang, so you get a s squared plus 4 plus b s plus c okay. So now at the bottom are similar, so that's mean we can equate at the top also. That's mean expand, I expand first, a s squared plus 4s. I expand directly. A s squared 4a. Is it correct? Bs squared 2bs plus cs plus 2c. Okay, now settle. We can compare left hand side and right hand side. The highest power in this equation is s squared, so the left hand side of s squared 2, right hand side a plus b. Next, s only 5, right hand side 2b. Next, constant, right hand side constant. Okay, so the unknown, there is equation 2 equals to a plus b, 5 equal to b plus c. Next, 3 equals 4a plus 2c. So there is 3 unknowns, which is a, b and c. You can use calculator with 3 unknowns. So you press your calculator, use your calculator, you will get a is 1/8. B you will get 15/8. And C you will get 5/4. Okay, so now you can substitute all the A, B and C values in your partial fraction. B t. Okay. So this can be separated between this. Since there is not enough space, let me do here. Okay, now we want to find, the idea is actually we want to find here yt is Laplace inverse of this function, but must be transformed into partial fraction first. So this is the inverse that we need to find. Laplace inverse of this is similar to Laplace inverse of this fraction. So directly I solve the fraction. Use 5 of this s. Okay, now solve the partial the inverse. You always look at the bottom. Since here is s plus 2 only, so it must be exponential. Exponential what? Exponential, since positive 2, so it's always opposite sign, negative 2. Okay. Next, this is, you look at the denominator or the bottom. There is s squared plus 4 plus constant. At the top there is s, so this must be cos. Cos what? Cos this. Square root of 4 is always 2. This is cos. Don't worry, if you write like this also can, no problem, no issue. Okay, next, this, you look at the top, at the bottom, s squared plus 4, s squared plus constant, and the top you look at, there is constant, so this must be sine what t? Sine this t. Since you square root of 4, so square root of 4 must be square root of 4. Because we cannot change the original item, just modify or fabricate, but do not change the original form. Okay, so that's mean square root of 4 is 2. 2 times 4, 8. This is Laplace is inverse, becomes sine. Square root of 4 is okay. Okay, if you do like this also no problem. So this, since we know that square root of 4 is always 2, this become 2 times 4 is 8. Okay. So that's the answer. The solution to the second order ODE, y double prime plus 4y equal exponent negative 2 with the initial condition given, is given by the solution of this.